Yesterday and day before, we talked about writing equations in slope-intercept and point-slope form. And then Monday, specifically, we talked about perpendicular and parallel slopes. Okay, so just a quick review. We have slope-intercept form, all right, y equals mx plus b. And then point-slope is this y minus y1, mx minus x1. Remember, they're named after what you need to fill them out. So point-slope, you need a point, x1, y1, and a slope. Slope-intercept, you need a slope and an intercept. Okay. Additionally, bringing back 2 days ago, parallel lines are going to have the same slope. Perpendicular lines have opposite reciprocal. Remember, opposite reciprocal is where you flip. So if we have 2/3, you flip your fraction and change the sign. So it would become -3/2. Okay? So keep that in mind. Parallel and perpendicular slopes and how they relate. All right? So moving forward, we're going to be starting on writing equations in different forms. So the first one we have, we're converting the following equation into slope-intercept. Okay? We need it to look like y equals mx plus b. Okay? We're starting here in point-slope form. Okay? So the only thing you have to do in order to get it from point-slope into slope-intercept, you have to isolate your y. Okay? Get rid of the parentheses and get your y by itself, and you'll be in slope-intercept. Okay? So in order to do that, I'm going to start out distributing my 3. Okay? So get that out, get that done. It's going to give us y minus 5 equals distribution. Remember, you multiply. So 3x plus 6. And then the last step, get our y by itself. So you do the opposite of subtracting 5. Okay, that cancels. Y equals 3x plus 11. Okay? So we have the same line, just in different forms. Okay? If you were to graph both of these, it would be the same line on a graph. Alrighty, so moving forward, we're going to be writing in slope-intercept form, again, y equals mx plus b, to a line that is parallel, right, parallel to this line right here, and goes through the point 2, 6. Okay, so remember we mentioned earlier, parallel lines have the same slope. So a slope of a line that is parallel to this given right here, if it has to be the same, it's going to be a slope of 3. Okay? Now we need to figure out where we start. So think about what information is given to us. We have a slope and we have a point. So therefore, which form should we start out with? If you're thinking point slope, you are correct. Okay, I'm going to rewrite it down here just so you guys can see. X minus x1. Okay, so this is just our point slope form. This is where we're plugging in. Okay, so now we just start the substitution aspect. So I'm going to do color-coded on this first one so we can remember how we did that last time. So I'll label my point as x1, y1. Okay, so y minus, substitute in your y1, in this case is 6, equals m, we determined as 3, x minus x1, and in this case is 2. So we have our information in point-slope form, but remember it's asking us to write it in slope-intercept. Okay, slope-intercept, we have to get our y by itself and just clean up these parentheses. Okay, so do what we did before. Distribute out. we're going to get y minus 6 equals 3x minus 6. Okay. Last step to isolate our y, add 6 to both sides. We get y equals 3x. And that's okay if your 6's over on this side cancel out, because that just means your y-intercept is 0. Your graph will go through the origin, okay? So y equals 3x is a line that is parallel to 3x plus 4, okay? All right, this next question is similar, except for the fact that it is now asking for an equation that is perpendicular. Sorry, my text got written over. But again, write an equation in slope-intercept form that is now perpendicular. What do we remember about perpendicular? 6 times 0 is 0. Yes, right, Imanol. Okay, so perpendicular is going to be opposite reciprocal slope. Okay, so thinking about 3, what is the opposite reciprocal of 3? So remember, opposite reciprocal, you got the negative part right. It is negative, but we have to flip it. So 3 is technically 3 over 1, which means it would then become 1 over 3. Okay, so very close. Our slope of a perpendicular line would have to be negative 1/3. Okay? And then we're just going to go back to what we were doing before. So we have a point and a slope. Okay, so again, I'm going to rewrite this. I personally like to rewrite my formulas. That's just me. You don't have to. All right, substitute in. So y minus y1, or 6, equals negative 1/3 x minus, and then x1 is 2. Okay. So now we're in point slope, but we still have to get to slope intercept. So we'll have to distribute out our negative 1/3. And this is going to be a fraction. I'm sorry, guys. Just bear with me during this. It's not very pretty. So we get y minus 6 equals negative 1/3 x. Remember, negative times a negative becomes a positive. So positive 2/3. All right. And then I'm going to write over on the side a little bit this way. Okay, so I add 6 to both sides. I'll do all the fraction hard work, don't worry. Okay, so the 6's cancel, so we are left with y equals negative 1/3 x plus 20/3. Okay. Alrighty, last example, we are going to be looking at a graph. Okay, we have to figure out the equation before we know what's perpendicular to the line. Okay, looking at the line that's given us, we know we have to have it y equals mx plus b. That's the easiest equation to start with. Okay, so m is our slope and b is our y-intercept. Do we have a y-intercept on this line? Okay, so our y-intercept is going to be right here at 4. So we know b is going to be 4 in this equation. And then what's our slope? Okay, remember we can look from point to point. So we go up 1, to the right 2. So we have a slope of 1/2, meaning the equation for this line is y equals 1/2 x plus 4. Okay. Now I can look at my question and figure out where to go now. So if we need an equation that's perpendicular, we have to have a slope that is the opposite reciprocal of 1/2. Okay? Remember, opposite reciprocal, you change the sign and flip your fraction, which would make your new slope -2 to give you a perpendicular line. Okay? Then we have our point, 1, 2. Since we are given a point and a slope, we want to start with point slope. Just for rewriting purposes, we have it right here. Okay? And then just substitute what's given. So y minus our y1 is 2 equals our m of -2, and then x minus the x value of 1. Okay? So we have in point slope form, we have our point input and our slope here. Now we have to get it into slope intercept, distribute out your 2. So y minus 2 equals -2x plus 2. I'm so sorry that there's a lot of 2's in this. All right, so I distributed my -2. We have this. And then the last step is to get y by itself. All right, so -2x, and then I add these 2's together, plus 4. Okay. And if you were to graph this, we have a slope of -2 and a y-intercept of 4. So I'll do this one in pink. So we just so happen to hit that same y-intercept. We have a negative slope, so down 2 over 1. And our line is going to be perpendicular. Okay? Remember, you can always check if your slopes give you a product of -1. So I took my new slope and my old slope. I'm going to multiply them together. You get -2 over 2, -1. Remember, product of your slopes, if it's -1, you are in fact perpendicular.